Hey there, we're going to learn a third uh, way to solve a system of equations. This one is called solving by elimination. So our objectives tonight are, how do I solve a system of equations by elimination? And probably even more important is, when do I use this technique? When's a good time to implement elimination versus substitution? So let's just talk big picture. All right, so when you hear the word elimination, you want to think about eliminating a variable. Instead of substituting an equivalent expression like we did with substitution, what we're going to do is we're going to force coefficients to become opposites of each other, so that when we add equations together, we're going to add equations together, they drop out because they're opposites. All right, so this may require no additional work. You might have a variable with opposite coefficients, like one equation has -3, another equation has +3. Therefore, if you add the equations together, they would drop out. Or you might have to multiply by a -1 to get them to be opposites. Or you might have to multiply one equation by a number to force it to force a coefficient to be the same. Or you might have to multiply both equations by a number to get them to be the same. Okay, so there's lots that could go on with this step one. Then step two, once you get opposite coefficients on a variable, add those equations together. That's going to eliminate that variable immediately. Then you're going to solve for the remaining variable. Then you're going to back substitute to find the value of the second variable. Check that answer and then write your solution, and then classify it. Same thing as with substitution. If you end up with an ordered pair, you have consistent, independent. If you end up with a true statement like 5 equals 5 or 0 equals 0, something that's always true, no variables involved, right? That's consistent dependent. That means that it's an infinite number of solutions. Whatever is a solution to the first equation is going to be a solution to the second equation. That's consistent dependent. Or if you end up with a false statement, something that is never ever true, like 0 equals 10, then that's going to be inconsistent and there's not going to be any solutions. So I forgot to get my pen out here. Bummer. So let's kind of go through this, and let's do one. So always check your equations and look to see what you have. Notice that I have a -3 here and a +3 here. If I simply add those equations together, I'm going to get 0y. My y is going to drop out. So let's do that. If I add those equations together, 4x plus 2x is equal to 6x. -3y plus 3y, that adds to 0. 0y, or just 0. -22 plus 16 adds to -6. Now I can solve for x just by dividing both sides by 6. And I get x is equal to -1. Now I can take this x is equal to -1, and I can plug it into either one of my original equations and solve for y. So now I'm going to go 4 times, I'm using the first one, 4 times -1 minus 3 times y equals -22. This is -4 minus 3y equals -22. I'm going to add 4. And I get -3y equals -18. So what's y? Y is going to be 6. So I get the ordered pair -1, 6. So then we just do mental math to check it. 4 times -1 is -4. Minus 18 is equal to -22. That works. And then 2 times -1, that's -2. 3 times 6 is 18, so -2 plus 18 Well, that equals 16, so it checks. I end up with a single ordered pair, so I get consistent, independent. Just like that. We're going to use elimination to solve this one. Notice that I have a negative 5y here and a negative 5y here. Now some of you say, well, if I just subtract those two equations, then my y's will drop out. And if you want to do that, that's perfectly fine. For those of you that need to keep the same process over and over again, I'm going to change the sign of one of those 5y's by multiplying the whole equation by negative 1. So I'm going to use multiply equation 2 by negative 1. All right? And when I do that, I'm going to recopy equation 1. So I get 6x minus 5y equals negative 8. And now I'm going to multiply equation 2 by negative 1 all the way across. It's going to flip every single sign. So then I get negative 4x plus 5y equals 12. And now I'm going to add those two equations together. 6x plus negative 4x, well, that's 2x. These drop out. Negative 8 plus 12, let's put a big plus sign here, equals 4. So x equals 2. Now I'm going to take 2, x equals 2, and I'm going to substitute it into one of my equations. And I'm just going to pick the first one. Doesn't matter. So I'm going to go 6 times 2 minus 5 times y equals negative 8. So I get 12 minus 5y equals negative 8. I'm going to subtract 12 from both sides, and I get negative 5y equals negative 20. And then I get y is equal to 4. So I get the ordered pair 2, 4. Okay. I'm going to check it just doing some mental math. 6 times 2 is 12. Minus 5 times 4, that's 20. So 12 minus 20, well, that's negative 8. And then I'm going to go 4 times 2 is 8. Minus 20. 8 minus 20, that's negative 12. So this is consistent, independent. Let's try another one. We're going to solve this by elimination. Notice that none of my coefficients are the same or opposites. Those aren't the same, and these aren't the same. So that means I have to multiply one or both equations by a number. I'm going to try and drop out my x's. So I'm going to multiply equation 2 by a negative 3. That way I get a different sign. All right? So equation 1 is, this is still equation 1, 6x plus 9y equals 15. I'm just copying that down, keeping things orderly. And now I'm going to multiply equation 2 by negative 3. That's going to give me negative 6x minus 9y equals negative 15. And now I'm going to add these. Add those equations. The x's drop out, the y's drop out, so I'm left with 0 on the left-hand side, and this drops out too. So I get 0 equals 0. This is always true. So this is always true. That means every answer to equation 1 is also going to be an answer to equation 2. So this is infinite solutions. And this is consistent, dependent. Okay? You okay on that one? Okay. One more. Let's try this one. All right. So again, look at your coefficients. Is there an easy fix? 9 and 5, that's not super easy. And then -4 and +3. So what I have to do in this case is that I have to multiply both equations by a number. I'm going to eliminate my y's, so I'm going to multiply equation 1 by 3, and I'm going to multiply equation 2 by 4. And when I do this, I get 27x minus 12y is equal to 168. Then I get 20x plus 12y. Oh, that should be a y. Let me erase that. Doesn't look good. Looks crumbly. Is equal to, what is that, 204? Now I'm going to add these equations together. All right, and I get 47x, the y's drop out, is equal to, oh, that's a 12, a 7, 472. Divide that by 47. Let me double check my math. I think I might have a problem here. Oh, it should be 208, not 204. You're probably saying, well, of course it is, Mrs. Westridge. Plus 168. 168 plus 208. Wow, I was way off. I need to erase. This is 376. Now what happens if I divide that by 47? Maybe I get a pretty number. I do. X equals 8. Woohoo! All right. So now I'm going to plug back into an original equation. So I get 9 times 8. I just picked equation 1. You could pick another one. Minus 4 times y equals 56. 72 minus 4y equals 56. Negative 4y equals 56 minus 72 is negative 16. So y equals positive 4. So I get 8, 4. Okay. So if it works, I have consistent independent. Okay. So let's just do a quick check. Let's do 5 times 8 is 40 plus 12. 40 plus 12, that's 52. And 9 times 8 is 72 minus 16. 72 minus 16 is 56, and that checks. So we're good to go. This is going to be our daily assignment. Let's do daily assignment. We're going to do this in class. All right. And I'll see you tomorrow. Thanks for watching.